Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem from the set called Properties of Inelastic and Elastic Collisions. Cart 1 of mass m is traveling with speed 2v0 in the positive x direction when it has an elastic collision with a cart 2 of mass 2m traveling with a speed of v0. All right, so at first, this seems like a really complicated problem. We have m coming in at 2v0. All right, and it hits 2m traveling at v0. So I'm going to hit somebody that is twice my mass, but moving half my speed. Okay, so I'm 200 pounds, I'm moving 10 miles per hour. I hit a 400-pound body, except they're only moving 5 miles per hour. So this is like a rear end collision. The light guy is moving fast and hits the heavy guy that is moving slow. But the key word here is elastic. So it's not like I'm hitting them and tackling them and becoming one mass. That's an inelastic collision. No, it's like we have those inflatable orb things where we hit and bounce off of each other. Like molecules do this. We're swimming in nitrogen and oxygen molecules right now. When they come close to one another, one little electron cloud repels the other electron cloud, but they don't actually make contact, and so it's really close to perfectly elastic. No permanent deformation, no heat, no sound, no vibration. The way we demonstrate this in lab is a little low friction cart, and there are magnets in between them. So North Pole gets close to another North Pole and it repels without actually touching. This seems like an impossibly complicated mathematical situation. It's actually two equations, two unknowns. I started doing all the fancy math, and then I was like, this is a conceptual question. They don't actually want you to find the final velocity of the little guy in terms of the initial velocity, or the final velocity of the big guy in terms of the initial velocity. They just want you to apply the common sense test. So first of all, what's up with their variable notation? V1 is the final velocity of the little guy. So after this bouncy collision, like, what happens to the velocity of the little guy? They're calling that V1. And then V2 is the final velocity of the big guy, 2m. So this guy comes in fast, and they want to know, well, what happens? The little guy comes in at 2v0 and leaves at what? V1. That's what they call the final velocity of the little guy. All right, so like I said, I started doing the fancy system of equations, the simultaneous conservation of momentum and conservation of energy. If you see elastic, all of that stuff is legal. But look, there are three ridiculous choices. Can the final velocity of the little guy be the same as the initial velocity of the big guy? Can the final velocity of the big guy be double his initial velocity? So if I collide with somebody that is 400 pounds, are they going to move away from the collision with my initial velocity? Can I hit a 400-pound person to make them move forward with my initial velocity? I don't know. See, I think that fails the common sense test. How about the final velocity of the little guy is the same? Could I not slow down after I hit somebody that is 400 pounds? I would say no. Can my initial velocity be cut in half? That's what this expression is saying. Can the final velocity of the little guy be half of the incoming velocity? Well, I guess so. But then can the final velocity of the big guy also be half? Well, no, the big guy's going to speed up and I'm going to slow down, right? Yeah, so I'm saying that all of these choices are disqualified. They fail the common sense test. I think it's this one, without doing all of the fancy system of equations. And there you go. I kind of want to read their hints. Way to go. See a step-by-step solution. The incoming kinetic energy is the outgoing kinetic energy. Yeah, 1m, 2v initial, 2m, 1v initial, right? Oh. So, hang on. They actually substituted in all of their choices and it satisfied this? Huh. That's interesting. Okay, so this is an expression of conservation of energy. Kinetic energy coming in is kinetic energy leaving. There's actually an m in all of these expressions, so that m cancels out. They substitute and check. All right. Well, here's conservation of momentum. Again, they substitute in and check. Huh. Okay. Well, no wonder I was having so much trouble with the simultaneous equations. I was actually trying to solve for V2 in terms of V0. I wasn't plugging in their solutions. Okay, well, there you go. You learn something new every day. Thanks for watching. See you in the next video.